Hello and welcome to the Cluster API breakout meeting for Wednesday, January 24th, 2018. We have a number of follow-up items from last week, so I thought we should start the meeting with those. If you have other meeting topics you'd like to discuss, please add them to the bottom of the agenda. The first follow-up I want to talk about was there's an issue we opened, number 463. It talks about how we should namespace API objects, and in particular, this relates to how to, whether we want to support putting nodes in a cluster that represent nodes in a different cluster. And we poked at this last week. A number of people went and put input on the issue, which was awesome. And so, Chris, do you want to sort of summarize where we're at and try to close this one up?
Yeah, sorry if it's kind of hard to hear me, but the consensus was we do want to do namespaces for all the cluster API resources. The main debate was over whether we put a field or annotation on the cluster object to let it know whether it's being locally managed or remotely. There was no good consensus on that, and so I'm leaning in the direction of not doing that, with the caveat that if we find that we need it, we can add it easily later. Annotations can be added for individual deployments that actually care about whether it's locally managed or not. And if we see that's used widely enough, we should probably figure out a better way to support it, or at least standardize on the annotation. That's the high-level summary.
So for anybody who hadn't looked at that issue, does that sound reasonable? Is that going to block any use cases that you know about?
A couple of us had talked about the field. I don't think it would block us in any way. It seems fine that we could add it later if we need to.
So I understand this. We'll actually, can we add a link to the issue? So maybe I can just read offline.
Yeah, so there's a link in the meeting notes. I don't know if you have the meeting notes handy, and I'll stick a link into, or if somebody beats me to it, into Zoom as well.
Okay, I'll grab it. Thank you. So one of the, I asked because one of the things that I'm currently contemplating is I want to have a cluster that manages other clusters, but I want some isolation. And so it's unclear to me how many remote cluster objects I want to store in my management cluster. I don't know if that.
What kind of isolation are you talking about there?
So any kind of configuration information, secrets. The idea would be that if the management cluster was compromised, how many customers would be affected?
Yeah, so then you're getting into sort of some of the multi-tenancy discussions around Kubernetes and how sort of strict of separation can you enforce. And I think part of that depends on what level of compromise is in the management cluster, right? If somebody can take over, a single pod in the management cluster and you can restrict the access of that pod to the rest of the system, you probably have a better story there, especially if you're running pods on different nodes where you have sort of the VM or hypervisor isolation. If somebody gets root credentials on your management cluster, no matter how you do the isolation, you're probably out of luck, right?
Right.
Yeah, I just want to mention that nothing in the cluster API right now insists that you have credentials. Some people do put project names and stuff like that in the provider config, but at least in our demo for KubeCon, we had a service account that was in the pod definition itself for the controller. So it's how you would do isolation with any Kubernetes application at that point.
Okay, so Chris, I think it sounds like we have a consensus here that we do want to support namespacing of resources. We are not going to add any special fields or necessarily enforce any standard conventions on what a resource in a namespace means. And if those sort of conventions come out naturally as people start using the system, then we can start enforcing those at some point in the future. I believe this implies we're going to add some new bits to some of our API objects, like in particular what namespace they're in. Is that correct, or do they already support that via the meta imports?
That's just part of the object meta.
Okay, so it's just we have to use it.
It changes how we register the types with the API server, but I think that's easily changed.
I think it will also affect the how we generate the clients, because there would be a minor configuration while automatically generating the clients if you want to make all of the objects namespaced.
Yeah, it has some slight implication on client generation, but that shouldn't be that difficult either.
Yeah.
Any code that uses the current client will have to change to add a .namespace call at some point, maybe, depending on which client calls it uses.
Okay, so I wrote down 2 action items in the notes. It sounds like we need to update our registration logic to be namespace aware, and we need to make sure that we get the client generation updated as well to be namespace aware. Do you know of any other implications that we should write down, or does that sound like it to you?
That sounds like the major ones, and I would ask that Fang look into that, since he's doing the API aggregation stuff right now, and we might as well just do it there.
Is the expectation then you run multiple controllers, one per namespace, or is control somehow configured to deal with multiple namespaces?
I don't think right. I don't think it's decided yet. So how to deploy the controller is still open question.
I think you could have cases for both. I mean, this doesn't restrict what the scope of the controller is. You could have a controller per namespace, or you could write a controller that works on multiple namespaces.
I guess I'm mostly wondering about the default recommended controllers. What would be the chosen strategy there?
I think I would personally recommend a controller per namespace, because you might be managing different types of clusters per namespace, and you might want to have different flags on your controller for each of those clusters too, even if they are the same provider.
Yeah, I guess I would also say that I think in some ways this is more of an advanced use case. A lot of the clusters that we would, create through tooling that were sort of singleton clusters that weren't part of a larger system probably aren't going to need to do this remote node management scenario. And this is something we're more building for flexibility and extensibility for people who want to run a cluster that effectively manages other clusters. I think in that scenario where you have this sort of master cluster that's managing remote clusters, controller per namespace or a single controller is sort of up to the person managing the master cluster. But for people who are just managing a single cluster that they've created, they will probably just have one controller that manages the local cluster.
But I think at this point, it also makes sense to consider the possibility where administrator of the master cluster might not want to reveal certain CRDs or certain or might want to keep some abstraction from the slave clusters, right? So in the node controller manager, maybe we want to have 2 different kinds of clients. So say, for example, one client which points to the master clusters API server, let's say for now registering the important CRDs, like machine deployment and so on. And maybe one more client which basically points to shoot cluster where we might want to look at the available nodes and so on. So, but it can be made generic in a way that user who has master slave kind of architecture can do it that way, but a user who has the same cluster, which is both a single cluster is both master and slave, he should also be able to do with a single flag. So that kind of thing may be helpful. Because certain CRDs or certain part like secrets that we are using for the AWS credentials in Node Controller Manager, right? So as an administrator of the master cluster, we would not like to give it to the slave clusters. So we would like to hide certain parts to the master. So 2 hooks of 2 clients may make sense.
So in that case, what I feel like your architecture would be is you let users talk to your master cluster to list machines. They would describe the nodes in their client cluster, right?
Yeah.
And Chris and I were talking about this yesterday. where right now we have a field, the machine specification, in the machine status part rather, that points, it's a node ref and it points to a node. But now we're talking about that node is not part of the same cluster that the machine lives in. It's actually in a different cluster. And right now, I don't think we have a way to represent sort of these cross API server resources.
Okay.
I mean, one way to do that is to, like, if you get a machine object and you want to look at its node, you list the cluster in the same namespace as that machine object. It has an API endpoint, and the node will always live at that API endpoint, whether it's the same cluster or a remote one. But yes, I agree. There should be a better way to note that. I'm just saying for now, that's one way you can think about it to get around that.
Yeah. So in the namespace, though we will have API server running for the slave cluster, but we would still expect that administrator of the slave cluster might want to have admin access on the slave cluster, right? So what we want is, maybe in our architecture, what we wanted was maybe we can hide specific things like secrets and machine class level of configurations. We keep those kind of CRDs on the master, and user still gets the benefit of the deployment or scaling up or scaling down. So some kind of subset of CRDs here and there, but that's more about creating a hook inside for two different clients and feeding two kubeconfigs. But maybe we might want to think of a generic way later, yeah, where we entertain both of the possibilities. Well, yeah.
Are you talking about maybe just RBAC rules saying they have list access to the machines, but they don't have list access to any of the secrets?
Not only secrets, but as an admin of a slave cluster, he can pretty much do anything that he wants to do, right? So we want to go one layer on top of it, so that even the admin of the slave cluster cannot really check the CRDs like machine or so on, machine deployment and so on.
Yeah, I think the use case is being described as if I have a master and slave cluster configuration, I want the admin of a slave cluster to resize the cluster. So how do they get access to this cluster API to add and remove nodes, but not necessarily do a lot more than that? That's at least what I got from this comment.
Yes.
So if the set of desired machines for that slave cluster lives in the master cluster, I think what Chris is saying is, can you put RBAC rules into the master cluster that allows the admin of the slave cluster to resize a machine set in the master cluster's API, but not add secrets or machine classes or whatever the other resources you want to protect are? And that would be RBAC rules in the master cluster, which are not then modifiable by someone who has complete control over the slave cluster.
Yes,
Yeah,
that can probably solve a problem at some extent, but it depends that what level of visibility we might want to give to the. So we might want to hide the complete master cluster from the slave cluster, but it's just the. Depends on different kinds of architectures. In one layer, we might want to give some visibility of the master cluster to the slave cluster's admin, and at some point, we might not want to give any kind of visibility of the master cluster just for the security reasons. RBAC is good; it's in place, but yeah. Just wondering, this trying to figure out a generic way.
Yeah. So I'm trying to think, like, are you talking about sort of splitting the resources across the clusters? Like in your case, you'd put the machine classes in the master cluster, but the machines and the machine sets into the slave cluster. They would reference classes in the master cluster.
Stuff like that. Yes, stuff like that. Some critical information goes to master where there is zero visibility for the slave.
I'm not sure how you can do that working with zero visibility. Maybe read-only visibility, but if there's zero visibility, then you're referencing an object that you can't see. Like, I guess your controller might be able to see both.
From master, there's still a visibility of the complete slave, right? So master can still do a lot of things. So.
Interesting. I think we're actually kind of veering a little bit into the second topic for the meeting anyway, which is that on Monday we had interesting hour-long discussion about the node controller manager, which is sort of what we're alluding to in this conversation. I linked from this meeting notes to a notes talk that we put together from that discussion, where I sort of put together a bunch of questions after reading through the design docs and the documentation and the types files to try and figure out how much overlap there was with that existing code base and the cluster API proposal that we've got going here. And I think there is a lot of overlap conceptually. There are a couple of edge cases like the one we're discussing now, which are interesting because the SAP folks have a couple of interesting use cases where they're trying to separate different personas, and in particular, a persona of someone who can sort of manage the underlying infrastructure versus a persona of someone who can sort of scale that infrastructure but not manage some of the details of how it's interacted with, which I think are not yet well addressed in an existing cluster API proposal. And so we've been thinking since then about sort of how to fold some of those things in. So I think that for me at least, that was a really useful conversation to have. So again, I linked the notes if people want to go take a look at those. I don't know if there's any follow-up we want to have in this meeting. I think that the hour sort of ran out before we got to a great conclusion point, or even sort of got to the next steps, because we were still going through some of the questions. So I think we'll probably have some follow-up discussion there about sort of the right path forward. Is anybody who wasn't at that meeting curious about any more details about what happened? I'm happy to recap some, or obviously we can't do the whole thing because it would take another hour, but any particular details?
I'm fairly interested in general. I have, a few days ago, I finally got the prototype AWS fork of kubedeploy kind of working, and I need to push that over to you as a PR just for discussion purposes. So as I'm looking at these node controller manager notes, there's a lot of interesting comments relating to vendoring, for instance, and management of secrets that are relevant. This is the first time I've looked at these notes, so I don't have a lot to say.
Great. Well, I'm sorry we weren't able to loop you in earlier because it sounds like you might have been interested in showing up to that meeting.
Not a problem. We can catch up.
All right. If there are no other comments, I'm gonna switch the order of the next two things on the agenda. One thing we talked about last week was trying to define sort of a standard machine lifecycle, if you will, of the sort of states that a machine goes through as it's coming up, being managed by the cluster API, and then eventually going away. And so Philip and I sat down. We sort of talked through these things verbally last week, but I think that was probably pretty confusing for most people. And Philip and I sat down and sort of drew up a picture of what this looked like and tried to describe what the different states were. We shared that out at the end of last week, I think on Friday, to give people a couple of days to look at it before this meeting. There were definitely some people who jumped on it and added some comments, which was awesome. But I kind of wanted to present it again this week with a picture and sort of talk through the states. One comment that was really interesting was Daniel Smith, who's the lead of the SIG API machinery group, mentioned that for other parts of Kubernetes, they explicitly did not create such a picture or diagram of the state transitions because they thought that would prevent them from being able to make changes going forward. And that is one thing I plan to talk with him about in the next couple of days, is whether this is just a bad idea to write this down and try to sort of codify what the states and the state transitions are, or if there's a subset that we can codify that would at least allow us to build some common tooling without tying our hands going forward. Assuming we can get sort of past that discussion, if you guys pull up the picture here, I can sort of talk through it again. And I think there were some questions about a couple of the states in the doc, and I think the people who asked those questions are here, which is even better. So I think draining was maybe contentious. So Martin had asked whether we should have an explicit draining state in the API, partially because you can do drains out of band. Is that the concern you had there, Martin?
Yeah, I mean, it's because if you are drained, then we might add some other condition, then some other condition, depending on the types of operations that you want to add to the cluster. So in the end, it will become bloated. In my opinion, we should just focus on the least amount of states that we want to support.
What do you think the minimum set of states that we care about is?
I mean,
basically creating, serving, deleting, deleted.
Yeah, and probably just more or less probably configuring or some, but those are optional. In my opinion, if you look at a normal virtual machine, those are more or less the states that you want to have.
Yeah, I think it's interesting because like if I look at what we did in GKE for doing upgrades, we drain before doing upgrades to move things off the VM because we delete the VM and replace it with a new one. And I think it is kind of nice to be able to see the progression of those steps. Like you can tell, am I still draining or am I actually reconfiguring or replacing this underlying VM as sort of two distinct things. Because otherwise we end up with like your machine is basically always in a serving state and you can't tell what's happening to it during that sort of long piece of the life cycle of the machine where like it has been created, but now it's just, is it always just happy and running after that? Or can we tell what's happening to it in the meantime? I think that's why we were trying to sort of pluck out some of these other states of, you can reconfigure a machine without draining it, or you can reconfigure a machine after draining it. And that reconfiguration could be changing the Kubernetes version, changing the container runtime, changing the underlying operating system. Like there are lots of changing parameters on the kubelet. There are lots of different things that we might want to change and be able to have controllers sort of track that state declaratively. And so I think some of these transitions might be more of like an internal API that we want to enforce between different controllers. So we have a set of sort of states that machines walk through that's consistent across in different environments. And maybe we don't expose all of those out to the end user in the public facing API, but it's more of like we agree that internally as we're building controllers, we're going to sort of implement the similar workflow here. Because I think Daniel's concern was if you put this in your public API, that sort of ties your hands going forward because people start to depend upon the states and the state transitions, which makes it hard for you to change them. Like how do you add an extra line, right? Or change where a line goes?
Or maybe just as a thought. So we tried to learn from the existing Kubernetes API for the node controller manager, and what we did is we basically added a last operation field. So the last operation could be create, delete, and in our case it could also be update. And then there are two layers. So one layer represents the machine state, and the second layer represents the machine phase. Yes. So in machine state, we got only very minimal, only 3 states, like it's processing, failed, and successful. So you can represent that the last state was if it was create, then it was processing, failed, or it got successful. And on the second layer, the real machine phase can be shown as part of the status, where you say it's either it's pending or it's available but not yet joined to the cluster, or it's running already, or somebody has triggered the triggered the deletion, so it's in a terminating phase, or it's completely unknown phase, or it's failed states or draining phase. So there could be more phases for the current status, but the state of the machine state could be minimal, and last operation could identify that what was the last thing that we tried to do, either it was creation or deletion or updation. That's what we did for eventually for controller manager, node controller manager.
So it seems like you're still exposing a similar number of states. You're just doing it across 2 different fields. Does that sound right?
Yes. So it's more of a layered thing. So certain controllers might want to rely more on the machine state than machine phase. So say for example, machine set controller might not want to check the machine phase, but it will just check that the last operation was create and the machine state for that was failed. So it can already act on it. It doesn't need to know what is the exact machine phase. Machine phase would be more for the user or human perspective, that what's really happening to the machine right now, whether it is available to join. If it's available, then it means that the machine is created but has not joined right now. If it's running, then of course it's running healthy, stuff like that. So we try to create 2 layers of the machine states.
Interesting. Yeah, I think what you said there that I thought was most interesting was that they might be targeted at sort of different use cases, where the states were more targeted at the higher level automation and the phases were more for people and human consumption. And I know that in the way we're trying to handle errors right now in the cluster API, it's also split that way, where we have like, here's an error string that's supposed to be machine readable, and here's an error that's supposed to be for a human, right? I think so. We're thinking about some of those similar concerns about splitting the different audiences apart, because it's often really difficult to do something that satisfies both of those audiences.
About that as well, we also have in Kubernetes we have events. So there were no discussions until this point for events. So some standardization or some ideas about more or less the events that we want to have on the machine resource.
Yeah, I think an event is, to me, one of those things that falls under the human audience category, right? Because of the way that they are tracked by the system and stored by the system. It's, I think, pretty much impossible to build automation that relies on events to drive it forward, because events can easily be lost, right? So yeah, I think for automation, you need something more persistent, like a field in your API. But you can definitely help the human audience and help debugging and understanding of what's going on in the system through generating events. And I don't think our prototype implementation generates any events yet, nor have we discussed sort of when it would make sense to generate events. But I mean, if you look at the state transition diagram, I think sort of each of those state transition arrows is a good candidate for something is changing in the system that you might be interested in. Like, we are now draining this node, we are now updating the OS, we are now recreating this node. Like, those all make sense for points when we generate events. So I guess the question then becomes, does it help the automation to know that know those intermediate states, or are the intermediate states more for human consumption, where something like events or your 2-level phase and status split makes more sense, right? Philip, I don't know if you have any thoughts. You're very quiet.
Yeah, so yeah, I wanted to hear feedback first. So I think like it might help us to try to like brainstorm what we would need in the higher level controllers, because that would drive probably the requirements in this like state that we need, right? So not sure if there was this discussion happening and I was not present, or like, for example, what do we need to create machine deployment which respects like disruption budgets and can do rollbacks, things like that, right? So is there anything that you would need from the machine itself?
So I think on our end, we haven't explored what the higher level controllers would look like quite yet. But I know that the node controller manager folks from SAP have those controllers in place, right? And they have this split of fields. And so I'm curious what they think is necessary to build those higher level controllers.
So I think status-wise, we would need at least, I mean, the machine set would not need to know a lot of details. It would just need to know that at certain point, a machine is in a healthy state, or you can always categorize or always bunch up certain phases and term it as a healthy, and and categorize certain other phases and term them as unhealthy, right? So machine state still considers the phase like the initial phase where it is creating, when we call it pending, and when it is in the available state and when it is running state, we categorize all of them as a healthy, and then we categorize the other phases where it's more of a failed, where let's say kubelet fails or disk pressure happens. So in all of these cases, the machine controller declares the state of the machine to be failed, and at that point, the machine set decides that now this machine has to be removed and needs to be recreated. And on one layer on top of it, machine deployment. So we don't really expect machine deployment to interfere much with the machines, we expect only machine set to interfere with the statuses of the machines. From the machine deployment, we only list out certain certain categories, like these are the available set of, what are the number of available nodes, what are the number of labeled nodes available, which are fully labeled nodes, which means which are the nodes which are fully labeled according to the label selector criteria, and so on. But the major part of reaction based on the status or the state of the machine is from the machine set. So maybe in future we might want to categorize or bunch up certain phases into a single phase and have a minimal set of state from where on which machine set want to react, and not a lot of phases where machine set gets confused that in this phase I have to do that and in that phase I have to do this.
So, for example, you mentioned the health status of the machine. So, do you distinguish it as like one of the states or phases, or this is like something separate?
So, currently let's say the pending state, which is the initial when the machine is created, we call it pending. Then when machine is created but yet to join, we call it available phase. And then once it's connected, we call it running phase, right? So all these three machine phases, we call them machine state as running or successful, I think. Yeah. So we call it a running machine state. So all these three different phases gets categorized as a healthy or running machine state. And in the rest of the cases where the machine phases, like it's failed, or while the deletion it failed, or something else has happened, like it has gone into the unknown state. So we have also seen the cases where your machine goes into a black hole. So you don't know what happened. I mean, networking has gone down or something, right? So the machine goes into unknown phase. So catch the word phase and state, yeah. So the machine goes into unknown phase. So that unknown phase, we wait for 5 minutes, and after that we convert that unknown phase into a failed. So that machine that initially for 5 minutes the machine was in a healthy state, but then it goes to the failed state. So that's what. So we more or less try to bunch up the phases into a minimal state, because eventually machine sets needs to know whether it should recreate the machine or not to maintain the number of healthy replicas. It doesn't really care whether machine was down from the cloud provider or kubelet went down or so on. Maybe I can try document these parts and put up in one of the proposal to maybe make it clear if it sounds.
Yes, because like the interesting part of the interesting to me the most is the part where this higher level controller needs to and so for example there is some unavailability budget. So for example, someone configured the cluster that no more than 2 nodes should be unavailable because of upgrades and so on, right? The rest of them should be a capacity for pods to be able to schedule. And so then like the higher level controller needs to understand that the upgrade should slow down because some node is unhealthy, or the state is basically like is under repair, and then then the update should go slower or stop until it's enough nodes are fixed. So stuff like that. I feel like we may need to actually understand that one node is unavailable for scheduling because it's drained. So this is something that we will not just wait and see what will happen because we know it's drained. That's why it's unavailable, versus it's just unhealthy because, as you said, like networking is flaky to this machine or something like that. So maybe distinguishing those two things is helpful for accounting.
That's a good question. So we have considered this part on the machine deployment controller, right? So in the machine deployment controller, we have exposed 2 fields, max surge and max unavailable machines. So max surge is self-explanatory, that number of healthy machines plus the number that you mentioned as part of the max surge is the maximum amount of machines deployment will any point in time create, right? And max unavailable machines is the number of machines which any point in time will be unavailable in the cluster while it is doing the rolling update. So deployment's job is to mainly to a rolling update, pause the rolling update, or do a rolling back. So as you said, if rolling update is happening and let's say 2 machines got updated properly and the 3rd machine is stuck, so at that point we wait till the 3rd machine actually gets up and becomes healthy. If it is not becoming healthy, then then the rolling update automatically gets paused. Yeah? So we have this thing, and the analogy is exactly similar the way the deployments work in Kubernetes right now for the pods. So if you see, when you are doing the rolling update for the pods, you have capabilities of pausing manually in between. So you can actually execute the command and pause the rolling update in between. Or if rolling update is failing, if the new pods, the new version of the pods are getting stuck somewhere, the rolling update automatically gets paused. So that thing happens in machine deployment as well. So eventually you will end up in a hybrid cluster, but it should not happen that all of the machines goes into an unhealthy state and stuff like that. So that was actually a very good point. That we need to stop rolling update in between from the deployment controller if things are not going well. And there actually we also plan to think of a scenario where we need to think one layer on top. So let's assume that we have applications running in the older version, right? And when we are doing the rolling update, we should actually also ensure that those applications are able to run properly on the newer version of the machines that we are transferring. So we should also check whether the pods are getting into the ready state. And that's where we actually need to check the PDBs, so pod disruption budgets. So we need to check those parts on the application layer. So we have not yet implemented the insurance on the application layer that the applications actually gets up again when the rolling update is happening, but we have that thing in the pipeline.
And similarly, and when you're choosing the next node to replace during your update, you should also be respecting the pod disruption budgets and slowing down the update, not just based on max unavailable on the machine deployment, but also based on the pod disruption budgets of the pods that are running on those nodes, right?
Yes.
So that was also pretty interesting. So this waiting for whether the pods can actually successfully run on this new version of machine. So how do you wait for that? Like what is the idea here? Do you have like another phase where you're like validating that this new version is fine for next few minutes before you proceed to the next machine?
So that part is yet to be implemented. So we don't have it in the implementation, but yes, what you said is correct. At some point, we will have to label the machine, or we will have to create a new phase for the machine, where machine might be healthy, but it might not be really ready for the rolling updates. So that's a good point. Actually, we need to think about.
So you still keep this. You still keep this token for disruption. You don't release it for the next machine until you are out of this phase or state or whatever we call it. Okay. Yeah,
so
makes
a
sense.
new phase or new label on the machine needs to be defined. But the thing is, the design of that thing is yet to be, it's not yet implemented.
Another thing is that, for example, the replica set needs to know which machine to actually delete, or, for example, arbitrary control, like the autoscaler or some autoscaler can actually tell it, I want to delete that machine via annotation or by some other means. So this, I think, should also be present in the, at least in the API or just in your controller. I don't know.
Yes, I think that's a slightly separate part where when we try to integrate the autoscaler, right? So it's really interesting that with the autoscaler, we will be able to scale up very easily. That's not a big problem. But when we do a scale down, we need to think about a lot of things. Yeah. So we really need to check that what kind of pods are running in it, or we actually need to prioritize the machines, that which machine should be scaled down first. Yeah, in that case, we still might want to put the intelligence inside the either deployment or machine set in a way that either we put a label or annotation on the machine object so that deployment can understand that I have got 5 machines, but this is the machine that should be scaled down first. Yeah, that is, I think, very interesting question, and I was also very curious, and I asked in one of the channel that I wanted to know that is there any plan from the cluster autoscaler guys to think or they already have a proposal for the design of integration of autoscaler and machine API, or
So there are two answers. One is that they already do the first thing you talked about inside the autoscaler itself. When they're looking at scaling down the cluster because they think that it's underutilized, they look for a machine to scale down that will have the least disruption, right? So they look for a machine that isn't running, singleton pods that won't come back because they're not underneath the controller, that's maybe only running system pods, or things that are in daemon sets, that they won't delete a node that will disrespect a pod disruption budget for something running on that node, right? So they already take all of that into account when they choose which node to delete, right? So they're not saying scale down this MIG by 1. They're saying delete this particular node from the MIG or the ASG. And I think they would want that same feature in the machine set of the machine deployment API of, we are smart enough to know which thing to get rid of. Please delete this one for us, not please scale down by 1 and I trust you to pick the right one. Because there are cases where the cluster is underutilized, but they don't want to scale down by 1 because it will violate one of these constraints. So that's your first answer. The second answer is I've been talking a lot with Marcin, who is from the Google Warsaw office and is part of the SIG auto scaling group, about integration between the cluster API and the autoscaler. And he was pestering me yesterday about like timelines and when they should start trying to rebase. And so I think there are discussions there. I'm not sure if there's anything that's been written down about what the autoscaler would look like or what the proposal is quite yet, but I can ask him because I should see him today.
Thanks.
Philip, did you have any other questions on this topic? I feel like we're petering out a little bit, but I'm not sure we've wrapped up.
Yes, I think we should maybe wrap up with some action items. So I think it sounds like the better understanding of the use cases of like what do we actually need as an input. So for example, we talked a lot about healthy versus unhealthy and those phases and states. So for example, the doc that Robert and I prepared like doesn't even talk about any health states, or so it's not. It's talking about like intended states, not all of the failures are like outside of scope. So it's not something that it's touched on. And I totally agree with you guys that it's important as an input for the higher level controllers. So I think we should have this full picture first before we can better understand. Like before we will be confident this is really the states or phases that we want to end up with, right? So at least I'm not comfortable yet with seeing this to the end.
Okay, how do we make forward progress on that? That sounds like a somewhat nebulous action item of we should figure out what we want to do. Is there anything more concretely that we can try to do, maybe before next week when we circle back?
So I think we should. So I will try to think a little bit more because this is not something I already have in mind about this healthy versus unhealthy. How this can be, or the failure modes, how that can be combined with the states. So that's I don't have any opinion on that. So I will definitely trying to figure out this part. But I can hear that there are already some proposals. So I also need to catch up on what is already there.
Yeah, and I think Hardik, you said, would it be helpful if we wrote something up about what we're doing right now? And I think the answer is definitely yes. If you guys could sort of like start a Google Doc, which makes it easier for people to comment on, that would be really, really helpful for us to help the better understanding of use cases, why you guys made the design decisions that you did, and how we can either fold some of those decisions into the cluster API or make sure we're being the same use cases in a slightly different way.
Exactly.
Yeah.
So if you could take that as an AI on your side, that'd be awesome.
Yeah, that's good.
Excellent. So the last thing I had on the agenda was to discuss the machines PR and the machine set PR. So the machines PR has been mostly idle as Jacob, as I mentioned last week, transitioned to working on Istio instead of Kubernetes. He put forward a proposal of how to wrap that up and get it merged, which I think everyone agreed to. And I need to go poke him to actually finish that off because this is not his full-time job anymore. So it's kind of a side project for him. But the plan is to get that merged, and then Fang, as part of moving things from CRDs to aggregated APIs, is sort of moving those types over into the new location. So I think that one we have a relatively clear path forward on, although I've been poking at him for the last couple of days and we haven't finished. So I'm hoping to get that wrapped up this week. The machine set PR has been open for a little while now. The Lutzi guys sent that one over, and I don't know that it has any comments on it yet. So I'm not sure if anybody's really looked at it very deeply. I guess Martin, it looks like you added at least one comment, which was a while back. I think a lot of the discussions we're having sort of swirl around things that might need to fold into that. So the discussion that we started on Monday about the distinction between just having machines or having machines and machine classes. And that, I think, in my mind, folds into the MachineSet PR in some ways, because I'm not yet convinced we need classes at the lowest level, but I think we probably need them at a higher level, especially to enable things like the autoscaler. And so I'm trying to figure out if there's a way we can propose a MachineSet API where we bundle machine sets or even machine deployments with machine classes at the higher level, where we expect users to want those ways to sort of stamp out lots of copies of things. But then at the lowest level, where we have machines, we don't have that complexity, so that a user who wants to just use machines doesn't have to worry about linking together multiple different objects. So that's sort of what I've started thinking about in terms of where I think that where we might be able to end up with something that sort of meets both use cases of having something very simple for users as they ramp up, but also sophisticated enough to meet the needs of the autoscaler and the needs of some more complex deployment scenarios.
Maybe just on a side note, we discussed this on Monday, but we could not get enough time on it. So we might also want to figure out a middle ground for machine class and provider config. So a middle ground might look like following. So you might have a single CRD for machine class, and the main benefit that I see from the provider config, right, is that we can add the arbitrary number of key value pairs, and we can make the machine controller smart enough to understand it and talk to cloud provider, where we don't really need to do API versioning all the time when something changes on the cloud provider, right? So what we can rather do is we can have a stable fields in the machine class, such as OS image or disk size and so on, which are already very stable and they don't need to be modified. But then we can have a new field in the machine class, let's call it provider config itself, and that's where we can put the arbitrary key value pairs. And the machine controllers would still, so if anything changes on the cloud provider, we do not really want to immediately change the versions and all. We can make the machine controller smart enough to understand and leverage that new features that came up on the cloud provider. You know, so I was just thinking through it, but thought this may make sense at some point, because details, redundancy of a lot of provider configs inside the machine looks scary to me. The only reason is that we still have an open question on whether we go the cloud init way or whether we really go the post reboot way, right? And if anyone decides to go the cloud init way, then the guy would want to put the cloud config inside the provider config, and that's where it will explode. So
yeah, I think I've seen that pattern in other APIs where you have like, here are the things that we are pretty confident about that we think are stable fields that are going to be consistent across environments. You know, you can even represent it instead of machine type, as you could say number of cores, and you could have a mapping on different clouds to what type of machines that means. And then you have basically like a extra key value chunk that you can add arbitrary other config things that will get passed through, right? So that pattern is established in other APIs that are trying to abstract different cloud environments.
And the cloud init part that I mentioned is actually something that can prevent a lot of us from directly consuming, because if my cloud init would be few KBs, and if you try to put it as part of the provider config, then each machine having that cloud init inside it will be really scary. Yeah. So
yeah, we talked about that a little bit with the Lutzi guys at KubeCon of having that cloud init, instead of being stored in the API itself, be something that's maybe inside the machine controller, right? So if the machine API object doesn't have like the entire cloud init, like startup script and all that sort of stuff, it just says like, I'm underneath this controller. The controller looks at that and says, oh great, I know for you, I apply this cloud init. That's another way to hide it from users, where users can't see it or modify it, but not sort of burden them with like it being dumped in their face as they're trying to look through the different API objects.
yeah, that's good.
We have 7 minutes, and Martin added something at the bottom of the agenda, which I want to make sure we don't run out of time for.
Yeah. So more or less right now we have like the machine API, but then everyone will add their custom bits, more or less, with like custom configuration, etc. So how does the API, the machine API server actually do validation for the code configuration on the running machine? So when you submit a new machine, you probably want to check if the configuration is okay for the provider. And the only way I can think right now is everyone to have like an external webhook for what was called admission control. Yeah, for external admission. Yeah, logic.
So Feng, I don't know if you want to jump in here. We talked about this earlier this week.
So for the because the current implementation is using CRD, and there's really no way to do any validation for the if there is valid configuration or not here. But when we move to the API aggregate API server, it's possible to add validation when you create the new machine object. So you can so in that case, you can like generate the error in such case.
Yeah, but this is only for the machine API. But for the custom bit, it more or less needs to work together with the API.
Gotcha. That part I don't have an answer.
Yeah, I think we did talk about maybe using admission controllers for that. The other option that we talked about is the machine controller could see that this new resource was created. The provider config, I think it's a string right now, but we talked about making that like an actual real type in Kubernetes. There's an issue open. The intent was for that field to actually be itself a Kubernetes object, right? So it still has, v1 whatever. This is an alpha object. It's for this controller. That's encoded in a way that we can do better sort of backwards and forwards compatibility and versioning on, that the controller understands how to read. So the controller can read that in, do its own versioning, and then spit back an error on the machine where it says, you created a machine with this desired state, and that desired state is invalid, right? And I think there might actually be an error type in the top level machine object that basically says like invalid desired state. And so that wouldn't be you submit it and it immediately gets rejected. You'd submit it, it would be sort of accepted as a possible desired state. The controller would look at that and say like, this isn't actually possible, and kick it back out. And basically take that machine and say, this machine cannot be instantiated. Likewise, there are going to be cases, especially as we talked about with the generic, pass a couple of extra fields to the underlying cloud provider that aren't represented directly at the top level, where we're going to get something in and we're not actually being able to know a priori whether it's a valid state. We're going to call out to the underlying cloud. It's going to reject that back, and we're going to have to say, sorry, you specified, it's an availability zone that doesn't exist, or you specified, an instance type that doesn't exist, right? And so we also have to take care of that case anyway. And so we can sort of use the error reporting mechanism in a similar fashion for both cases. And that's not to mention things like you ran out of quota, we can't scale you up. Like that's another case where it's more of a transient error, where you could add quota and it could then later be reconciled. There are going to be states where you're sort of in a permanent error state where your config is just plain invalid.
What would be a time at which how would you clear the error, I guess, for the transient cases? I'm not too familiar with the API, how things are working out from terms of like generic Kubernetes APIs, but what would be a pattern there?
So if there's like a quota error that's a transient case, I could imagine the machine controller saying, I could try to instantiate the machine. AWS told me I had no more quota for that project in that zone. I'm going to wait, and maybe I'll try again in 10 minutes. Or if that fails, maybe like have an exponential back off, and I eventually start trying once every hour. But I will keep trying. Like I'm not going to give up, because I know that this state could be resolved externally by an actor going and changing quota. Whereas if you try to create a VM and AWS says like, sorry, you specified a machine type that doesn't exist, there's not really much point in trying again. So you can basically put the machine in sort of a terminal. This desired machine set you gave us is not going to ever work. So I think it's useful to distinguish between those two cases.
Makes sense.
Does that help, Martin, or are you still confused?
Yeah. Well, yeah. There's a transient and then some. Well, I would really like if there was a way just to check for like if this type is a string or whatever that can happen during the initial admission of the machine object. But yeah.
Yeah, so I think we can look at admission controllers for that. I think Chris had to drop off, but I think he mentioned that it was possible to do that with admission controllers. So that's one way to look at it. And if we're running our own extension API server, presumably you can stick admission controllers in that API server to do some of that initial validation also. Which is a little unfortunate because you're decoupling it from like the actual controller code. And so you don't want those things to get out of sync. But it does still give you the flexibility of being able to have different machine controllers with different input validation without having to surface everything at the top level and try to generically abstract across every cloud, which is, I think, something we were really scared of trying to do. Like we're not trying to build another Terraform. So, all right, with that, we are just about out of time. Thank you for everyone coming. This has been a very productive and fruitful conversation. I will be out of town. I'm out of the office next week. So I'll find somebody else to run the meeting. Please continue to show up. Don't not show up just because I'm not here. There's a lot of stuff to discuss, and I look forward to watching the recording and reviewing the notes when I get back. And I will see everybody in 2 weeks. Thanks.
Okay. Bye.